Hello, everyone, and thank you for joining us for another exciting installment of the Customer Success Skills Exchange. Very, very excited about the topic today. We're going to do a CI deep dive. Special shout out to Cristiano for building the demo and the presentation. I'm really excited for this topic. I know it's been a huge ask from many of you. So without further ado, Cristiano, the stage is yours.
Thank you. Thanks, everyone. I start sharing my screen and let's see. Can you hear me? Can you see my screen?
Yes.
Yep. Great. The suggestion is to follow the presentation also from the website, because in the related notes you can find a lot of interesting links related to what I'm sharing. So especially after this meeting, I suggest you to give a look to all links that you can find in the notes. So let's start. The topic of the presentation is CI and CD. Probably today we will focus more on CI, just for timing trouble. So this is our typical image that we know. I would like to go a little bit deeper about what we can really do inside a CI pipeline today. So let's start with the pipeline anatomy. This is the really basic instance about our pipeline. I have just one stage. I have 3 commands launched in a row, and this is really the simple, the easiest scenario that you can find. But let's try to understand how a pipeline can scale, can grow, and become a little bit out of our control. So the first point is managing the pipeline file. It's not sustainable to have a pipeline file that is containing 200 or 300 lines of code, and this is not so uncommon. I found in some customer really longer pipeline. The approach is the same that you should use where you are coding. If you have too long file, if you're including too many different pieces of code, the suggestion is to split them. How we can split them? We can include the file inside our pipeline, and this file can have different origin. We can use a local file coming from the same project. You can use external file from other projects. You can use one of our templates that we are using and that we build on AutoDevOps, or we can use a remote file. I could have, for instance, a web server that is just exposing a plain text file. I can use that as a pipeline inclusion, or for instance, using another instance of GitLab exposing that that file. So this is a great advantage looking at the CI file to understand each stage, what it's doing, and where I can find many details about my code. But go forward. We can also change the file name or the location of our CI file. For instance, the typical use case is a customer that have a large organization, and who is managing the code is not who is managing the pipeline. So if you need to split the ownership or just the management of these two parts, pipeline and code, you can define inside the project a different location, or just a different naming. So what about efficiency? We can use only an exact to decide that a job has to be executed just on some kind of branch or naming convention, but pay attention because actually this feature is a candidate for deprecation. What we can use instead of this is the rule. We are going to see how to use them. Pay attention to this because it's a function that a lot of customers are actually using. And so it's a risk for our future migration and upgrades. Basically, we can define a set of complex rules that, basing on the exit of the rule, can define if my job is going to be executed or not. If the rule set will exit as a true, my job will be executed. If not, the job will be skipped. This is giving you a lot of advantage. For instance, the typical use case is regarding security check. Some security check could take a lot of time, and maybe the developer don't want to wait for that time because he's just working on his local branch or a secure stage or testing environment. So it's not that moment where the developer wants to challenge with security. With these settings, you can just keep what is really important for you. Has been added, just a moment. Okay, I take this opportunity to show you something more. When you find a piece of code or where I'm talking about a specific feature, I created a snippet of the code inside our GitLab demo environment where you can find a piece of code that is working, and you can find also the link to our documentation. So you are able to find exactly what you're looking for. Like in this case, I want to know where it's been introduced. It's been introduced in 12.3 version. And this is available for every single feature that I'm going to show today, okay? So if you look also at the previous slide, for every single piece of code, there is a snippet and a link to the documentation. The difference between 12.3 and 12.5, it's the complexity of the rule usage. So it depends from how many the rule is complex, okay? Let's go forward. We can also use before and after script to prepare or to clean, to complete our job. This is a great advantage when I want to have in my script part just what I need. But if you're going to look at the optimization, usually a custom image for the build environment, including the before script, can let you save a lot of time. So my suggestion is evaluate every time what you're putting in the before script or the common operation that you're doing during your job. Put all of these things inside a custom Docker image that you can cache. And in this way, your build will have a strong improvement on timing. Let's talk about the cache. We receive a lot of questions about how can I use the cache to speed up my process. It's important to understand that we have a lot of different cache. It depends from my platform. It depends from my building environment. If I'm making the build on Linux virtual machine, I have, for instance, the local apt cache. If I'm building on Docker, I have the Docker image cache. If I'm working on Kubernetes, I need to define an external S3 storage to use a shared cache. And talking about the artifact, I can expose an artifact and use this as a sort of cache. So it's never about one single cache. it's never about the same kind of cache, and you need also to pay attention to the cache, because you risk to expose your build to a garbage collection problem. So it's really important to define exactly and to trace what is impacting your build timing. Sometimes the problem is regarding the size of my repo. It's usually happening with a mono repo application when I have tons of different files and resources inside the same repo. In this case, you can define a static volume for your runner, and you can change the Git strategy. Instead of fetching the whole repo, you can just ask to the build environment to pull the new updates from your Git repository. Obviously, you need to have a permanent storage behind. We can also use a pipeline to trigger another pipeline in a different project. Sometimes the timing is not just about it's not just about my process. I can see a long pipeline running, but maybe half of this is out of my department, so it's not important for me, it's not interesting. Or maybe I have a lot of different pipeline that are using the same piece of code for the deployment part or for another piece. With the triggering, you can reuse the same pipeline from many projects, passing intermediate job between them. So you can trigger an external pipeline. Also in this case, you can find some snippets down. And you can also have the child pipeline. If you have a long-running job and the result of that job is not blocking your work, for instance, I have a long security scanning again, but I'm in the staging environment. I don't want that my build is stopped from the security test because I'm still working on the code, but I would like to have the result anyway without waiting for the next step. What I can do is using a child pipeline. I can detach the security scanning, for instance, just in the staging environment. So I'm able to complete my pipeline. I can test in my review app my application and see my change. But at the end, before to decide to promote my application to the next stage, I'm able to give a look to the report for security scanning or whatever. Same if I have to upload a large artifact in my artifact store. I can complete the build, and when all my tests are confirming that my build admit successfully, I can just trigger a child job to make the upload on the artifact store. You can also call a pipeline that doesn't exist. You can create a script that is dynamically creating the last piece of your pipeline, and you can then trigger that. In this case, your pipeline, your child pipeline, will be totally dynamic. So you don't need to define and write every single use case, every single parameter that can be changed, but you can just use a script to generate that. Sometimes another problem is relating to the dependencies. You know that when we have a stage, every job will start at the same moment. And before the next stage is starting, we need to wait for the completion of each job in the previous stage. Especially where you have a lot of services or a complex environment, you could have a dependencies tree that is not so linear. So you can define directly dependencies job by job, and in this way, the next job will wait just for what you define it. So we are going to break our typical dependency schema, and the users is able to define what he wants job by job. So no more dependencies. Sometimes the problem is exactly the opposite. You have too many builds, too many jobs, and you are going to hit a resources that is not so available. You can define a resource group, or many of them, to define a resource that can handle a job, just one job in the same time. So in this way, if a job is going to handle with this resource, the scheduler will wait and will pass through that resource just one job by time. This is helpful, for instance, if you have an endpoint that is not responsive, if you need to use a storage procedure that is not so modern, and so on. So you can also define resource group to avoid concurrency job on a specific resources. It's important also to manage the life cycle of our job. You can define job by job, timeout, if a single job is allowed to fail or not, if it's safe to stop that job, or the number of attempts that I can retry that specific job. This is really important because if I have a job that usually is taking 10 seconds, have no sense to wait for 2 minutes before to get the failure. This is just consuming resources and wasting time. Also, having a longer timeout can let you don't notice a problem with performance. If my normal build time is 10 seconds, it could be good till 20 or 30 seconds. After that, I have a problem in my performance, and it's important that I can notice that. So keep the timeout near to double, sometimes 3 times the amount of time that you usually need for your build. Don't put just the full timeout for anything, ignoring this. It's really important. There is any question till now? Okay, great. So GitLab integration, let's see how we are able to interact also with the other tool. We know that we are trying to cover the whole life cycle, but sometimes a customer have an existing tool that is using it is not easy to just remove everything else and migrate to our product. So let's see what happens. In GitLab, we use many third-party tools, and we are able to deploy them with our GitLab managed apps. And we use them in our core feature, like for build or security scan. You know that a lot of our security scan engine are not built by ourselves. We are managing the integration. Same for a lot of GitLab managed apps that we are deploying. But what about if you have to integrate with a tool that we are not supporting? In our pipeline, you can define the image and everything you will find running your job. Basically, if you are able to run a tool in a shell, you are able to integrate that tool with GitLab. Or if a tool is exposing an API, you are able to interact with GitLab. Let's see. This is a real instance. I wanted to use load tests for the staging environment to ensure that my application is stronger enough. I used it in the past Locust as a load test for web application, but we don't have any integration pre-built with Locust. So let's try to understand how we can integrate this. I defined my stage. Obviously, I added the stage in my stage list in the position just after the stage environment. I define my image. The Docker image in this case is provided by Locust itself. I'm using parallel parameters. Parallel lets you run the same job many times in the same moments. So this is a load test. Every single pod will generate a specific amount of load on my application. Changing the parallel parameter let me decide and scale up my firepower during that load test. I define my target using the environment variable, as you can see, and in the script part, there is the real locus command that I could use from any shell to use the locus product. So I give to locus a target that is in the variable that I defined before. I give to locus a locus file that is the definition of what the web client have to do during the load test. In this case, it's just a normal curl on the main page. I define the number of clients that I want to simulate and the duration of the simulation, the load test. And I ask to Locust to export all the result in a CSV that I will expose by artifact. So you have a link to the real project that is working inside the notes. So if you want to give a look to that, it's real. This is the typical instance about using a product that is not really out of the box with GitLab. But this is not the only instance. Here we have an artifact store, JFrog. You know that a lot of our customers are using JFrog. JFrog is providing in their documentation basically how to implement the artifact upload inside our pipeline. So you can find a complete description, and here you can find the piece of the CI/CD pipeline. As you can see, it's totally the same logic. I prepare the image. They are starting from a Maven image. They install JFrog, make the first configuration, and after that, they're using JFrog like in any kind of shell. So the logic is the same. It's not important what you are implementing. You are able to implement everything that is exposing a CLI or an API. Chris,